and welcome back to another 3D Hangouts. I'm Noah Ruiz, designer here at Adafruit, and joining me every week is my brother Pedro.
Good morning, everybody. I'm Pedro Ruiz, creative tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right, this is where we combine 3D printing and DIY electronics to make inspirational projects. Hello everybody in the Discord chat room. If anybody would like to join in on the action while we're doing the live show, you can head up the Discord server, say hello, and
come hang out, ask questions.
Sorry. Good morning, everybody.
We are hanging out in the Discord, as you said, at discord.gg/Adafruit. We're also hanging out in the YouTube chat, Facebook, LinkedIn, I think Periscope.
LinkedIn? I think I turned LinkedIn off, sorry. Or maybe it was Mixer? Yeah, anyway. Hello, everybody in the chat room. That's where we're hanging out. Huge shout outs to everybody in there. We'll do some shout outs. Andy Calloway's hanging out. Blitz City's hanging out. Hey Liz. Mr. Certainly Bruce is hanging out as well. And Yanni Skoo is hanging out as well. Hello everybody. Again, if you got any questions, go ahead and drop them in the live broadcast chat room. It's on the sidebar there. That's where we're hanging out. That's where the chat is.
Over on the YouTube chat we got Fed Inventor, Hobby Product, and Elizabeth Havona.
Hi.
Good morning, everyone.
Yeah, we have some fun rainbows to share. So let's go ahead and kind of run through the intros. Okay, the first one is CircuitPython Day. It's coming up. It's 9/9. We have more events and more info as the weeks progress and we start to plan for that. Speaking of CircuitPython meetings happen every Monday at 2 p.m. So if folks are interested, check it out. It's a great way to come in and say hello. What you're working on, and get an insight look at what the devs are working on as well in the community. It's not just Adafruit folks, lots of folks are in there, so check it out. It happens every Monday at 2 p.m. and it is a live kind of recording in the Discord server, and it's in the CircuitPython chat room, so you can check it out there. If you'd like to contribute, you can ask to have voice, and then you can talk if you want to talk about your project or something like that. So check it out every Monday at 2 p.m. Eastern Time.
Adafruit is open safely and shipping orders at this time, usually within 1 business day if you choose overnight shipping.
That's right, we have a page, adafruit.com/opensafely, if you'd like to get an insight as to all the different things that Adafruit is doing to keep everybody safe. Check it out. Some of the latest things is Adafruit is testing surfaces at the HQ in New York, and they're using phthalagen surface testing stuff. And Phil put together a blog post and some lovely images of Lamar swabbing all the different surfaces at Adafruit, and thankfully everything came out negative. So cleaning up is good practice.
That's right, wearing masks, being socially distanced, wearing gloves, it's all working. And we're going to be doing these tests every single month.
Yeah.
So.
Intense sanitizing protocols. They're here to stay. Alrighty. There's all the info there if you're curious about where to get the test and where it was applied. You can check out the blog post. I have it here. Okay. Let's keep going. Adafruit Daily is a great way to get some daily news, projects, that sort of stuff. If you'd like to check it out, go to adafruitdaily.com. That's where you can subscribe to all the different newsletters, the latest being the IoT Monthly, and then kind of our favorite one is Python on Hardware, right under the 3D printing one. So check that one out. And then we have once a week product-focused newsletter. You can get that at adafruit.com/newsletter. Subscribe to that if you'd like. None of these subscriptions are automated. Like, they're automated, but they're not sent to you if you don't subscribe to them, because that would be bad. And a lot of folks do that, but we don't. So that's nice to say. Yeah. Let's see. Yeah, I think we're ready to start the show.
Let's go ahead and check out this week's awesome project.
Okay. Let me go to the overhead, the lower head. Yeah, so this week we put together a nice little 3D printed case. We're using the NeoMatrix 8x8 LED display. We got a feather on the back. Put it all together in this nice little package, and we're using that awesome new material dubbed black LED acrylic. This stuff is really nice. We had some in stock. It sold out. Thanks to everybody for buying it up. Thought I'd make a project this week with it. It doesn't require CNC milling. Of course, you could CNC mill it, but you could also just score it and cut it and snap different shapes out, like a shape that would fit your NeoMatrix. So this is it. Let me go ahead and put it together again, and then we'll talk about it. So we got our 3D printed grid here, which is separating the light that are on the PCB here, the little NeoPixels. There's 64 of them, and they look really awesome in this black LED acrylic. They got a built-in slide switch here for turning it on and off. It snap fits together, so we got these two edges here that snap fit it together. So it looks really nice. I have the code just running one of the animations because I was doing photos and I forgot to change it. But one of the really cool features that I like is that it has the Proto FeatherWing. So if you do want to swap this out for something with like Wi-Fi connectivity, like the ESP 32, huzzah, or maybe you want Bluetooth, like an NRF featherboard, or the Sense is also another great one. You can easily swap it out, and you could even kind of customize the headers so that you can have stacking headers, and you could probably even fit like 2 dual headers here, so that'd be kind of neat. Yeah, so if you had like multiple feathers, maybe you wanted to add a RTC, a real-time clock, make yourself a little clock or something, that could definitely work. So yeah, but I wanted it to be modular, so that's why I added the Proto FeatherWing. It's a great way to get lots of different connections, lots of different pins. Has tons of power and ground pins, so if you want to power other components, you can totally do so. I got this little 400 milliamp LiPo battery here, just because it fits so nicely in between the feathers here. But you could add some, like originally, I added some standoffs here with like the M25 standoffs. That way you can stick a bigger battery if you do want it to be portable. If this is going to chill on your desk and you're writing some code, I would recommend just having it plugged in through USB and then just power it that way. So you can do that. So let's go ahead and take it apart and get a look at this acrylic. So the acrylic just rests in this cover, and this cover is kind of what has those snap fit features. You can see on the side here, that's where the snap fits are. Everything else is just kind of flush. It doesn't have any snap fits other than the sides. So this just kind of presses in there. This is from Adafruit. It is a little bit thinner than the stuff we got from Tap Plastics, which is right here. And I have kind of 3 different versions here, so you can see kind of all the different variants. So this is like your regular smoky acrylic. I hear people call it smoky acrylic, but it's normally just transparent. And it does not provide any type of diffusion. It's just like a cool tinted acrylic that's completely transparent. Doesn't give you any diffusion. And this is normally what you would get like at you know, at whatever hardware stores sell it. Yeah, and there are different colors of this. Great for like if you need to see inside something but still kind of have it protected. So that's that. This is from Tap Plastics. It's from Tap Plastics, and it's a little bit thicker. So you can see here that it's kind of a little bit more softer because the material is thicker, making it darker. So this is darker, and then Adafruit's is slightly more opaque because it's like 0.2 millimeters thinner. But you really can't tell the difference. The case accommodates for both of them if you want to have them. And it even accommodates for this one if you wanted to have that in there. So that would work too. So yeah, if you put it over the two, comparing it like that, you can see, yeah, okay, this one's a little bit more bright because it's lighter, and this one's just a little bit darker. There you go. And then if you really want to compare, there's just, wow, it's like magic here, the way that works there. And then of course, the more distance you have, the more softer diffusion you're going to get, but you still get some kind of sharp edges there because of the way the light's catching the edges there of the grid. So there's that. So the grid itself is roughly 10 millimeters tall, so that is kind of thick. You know, I tried going half, like 5 millimeters, and it just doesn't create that effect. You really do need a minimum of like 10 millimeters of distance to get this soft, even, diffused look. So that's some of the things that I found there. Another thing to make this work is I had to add these little cutouts here in between all of the walls so that they can accommodate for the onboard capacitors. So I'm going to unplug this so you can get a look at the capacitors. They're all placed in between the LEDs. And they all kind of go down in this kind of grid. So I just had to make sure that those cutouts were deep enough so that this compress fit through the PCB mount, but also become flush with the PCB. So now all of those surfaces are flush with the PCB, and because there's cutaways for the capacitors. Yeah, so that's how that works. Let me take that off. And it just press fits in here. It doesn't have any like kind of snaps on the edges. It just kind of fits in between the gap here between the PCB mount and the PCB. The PCB itself isn't really secured in there, like it literally just falls out. And that's really nice because it's easy to take it apart. The standoffs are built into the PCB mount, and they have these little pegs here. And the way they are designed is so that the outer standoff is kind of where the PCB rests, and these little pegs here are what actually go through the various mounting holes. There's quite a few of them, which is great because it has plenty of mounting points. And yeah, the Proto FeatherWing has M25 screws and hex nuts that secure it to these tabs here. And it's strategic in the way that like I cut an opening here just so that the cable here can kind of pass through here without having to disassemble it. So that's why I had that there. You can tile these together. There's plenty of pads here for tiling multiple of them together. You have your data out pins over here, along with another pair of voltage and ground. And then this is where data in is, and I have this connected to a JST connector, a 3-pin JST connector, so that I can disconnect it easily if I need to. But so far, I haven't had to take it apart because of the way that I made this cutout here, so I can kind of pass the PCB through here. And yeah, it's somewhat symmetrical, so like if you wanted to rotate this way, I suppose you could, but because of that cutout, you want to keep it oriented this way like that. So you can read the text and then see that my switch is up there. And then we have these edges here. These are little nubs here. They're about 2 millimeters long, tall. That way they snap into the little edges here of the cover. So you can kind of see how that works. It's funny because like all the pieces have to sandwich together in order for this to kind of like work, right? Because like it all kind of sandwiches together to snap fit correctly, which is nice. So yeah, you got your NeoPixel PCB that fits in there, and then you just want to line up your cuts here. You see I have it oriented wrong, so I have to rotate it a little bit, and then this fits in like that. That clicks in like that. It won't fall out. And then you can put your acrylic piece in here, and then the acrylic piece in there. Make sure that the reflective side is like on the inside, and the nice soft matted surface is on the outside. There is like a pretty big cutaway here, and that is to accommodate for like the switch. So what I did here differently with the switch is it has a built-in little holder with 3 walls, and it just holds the switch in there. We tend to do this type of design for all of the projects that have these little switches, and it's just a great way to kind of get it in there. There's no glue holding it. It's literally just the tension of the walls here that are holding it, and then you have a hole here that exposes the actuator so you can turn it on and off. And that's wired to the enable and ground pins on the Proto FeatherWing. Yeah, with 2 wires there. What's cool about it though is that it has a slight extrusion here, right? So you can see that it's not flush, it extrudes out, and that allows the cover to have that opening so that it has a nice sort of feel to it. So you put it all together, and then let me make sure that the cutaway is, yep, oriented properly. Let's see, is there something? Nah, it's just make sure that the wiring is not getting kinked or anything like that. It is. That is why that cut there is important, so that the wire can kind of come out like that. And then you can kind of stuff this in here. And now you have that nice and kind of put away. All right, the last thing is the cover. So here's that cutaway, and you'll see that it lines up nicely with that extrusion for that slide switch. So it kind of gives you like this flush surface, but like this nice kind of chamfered edge here, so you have some you can kind of close your eyes and feel it. Yes, it's there. So it kind of gives you a visual indicator of where it is. And I turned it on, but the board isn't in there yet. So here's the board, battery's already in there. The reason why it's powered is because there's no slide switch wired to it. The slide switch is wired to the Proto FeatherWing. So once I plug it in, if the switch was off, it would turn off like that. But there you go. So there's the assembly. Nice detail there on the assembly, and a nice flat edge here so that it can stand up.
It is an awesome use of grids with the black LED acrylic. So, Mr. Certainly Bruce has a request. What does it look like having both tap plastics and Adafruit diffuser combined?
Sure, let's try it out. It's gonna get real dark, so we put that one up front right there. Here we go, guys.
Oh, no.
I don't know. The universe might break here. Bump. Yeah, it's very blurry. It looks like my camera's blurred, but there you go.
Oh yeah.
Yeah. It's just like adding more tint, you know?
Mm-hmm.
Maybe put these two together. What happens there? Not much.
Ah.
Just makes it darker.
Looks like it makes it more clear on the camera.
Interesting enough, like the brightness here is set to like 0.2. 0.2. Because I actually ran into some power issues. It wants 5 volts, it really does, but I'm only giving it 3, and it's not very happy.
And then AAA on the YouTube chat is asking if this code could be adapted for the ambient light, like the TV flicker.
That would be super
cool. And I linked him to one of the guides that we have on fake TV lights for engineers, and it's using a Metro.
Nice. Yeah.
So you might be able to adapt that code.
Yeah, is it Arduino or CircuitPython?
I believe it is Arduino. Yeah, it's Arduino.
Yeah, well, that's great. You can easily double-click the reset button and then upload the Arduino firmware, and you're on Arduino land. And then you can double-tap the reset again and then go back to CircuitPython land. That's what's one of the awesome things about the Feathers and just the UF2 bootloader, is that you can easily switch between Arduino and CircuitPython.
And then another question on what the CRI, I think it's the color reproduction index.
Right, for NeoPixels? There's a data sheet that would tell you, but it's
only
not
because it's not white RGB, so it doesn't have the dedicated white pixel or LED color.
And what's funny is we do the NeoMatrix now, or not now, but it comes in different flavors. So there's some that have the cool white LEDs, the warm white LEDs, RGBW. Yeah, and I'll show them to you. The RGBW right here under the drop down. You can see there's different ones.
I forgot.
What I did is I just plugged this in through USB, and then I have the Mu editor, and I just uncommented the animations so that I can have all of them. So you can see here that there are different animations and colors. So there you go. We'll look into the code bits in just a second here as we queue it up. All right, so let's head on over to the Learn guide. So you head on over to learn.adafruit.com. You can see the project there is posted. The overview page just covers all the parts that are used. Most of them are in stock. Actually, maybe not in stock right now, but it's fine. You could sign up. You can sign up to be notified when they are in stock. Yeah, so we got the NeoMatrix. That is in stock. Yay, and so is the Proto FeatherWing. That's nice. There's also some other odds and ends, like the standoff hardware kit that we have and the various JST connectors. Those are nice. Battery is optional, by the way. You don't need a battery if you don't want it to be portable.
And we have a bunch of examples with the Matrix. We have Nico Tuba asking, what is this for? What can you do with it? Can you show some examples? So it's a display, so you can have it display weather or text or... Yeah,
currently it's just a good kind of way to showcase the new LED animation library for CircuitPython. That's kind of what our inspiration was. Like, hey, let's make a nice case for it and get that black LED acrylic in there and try to get this effect.
And then beyond that, using your imagination, these are used in a lot of props. So a lot of the movies that you watch, a lot of the cosplaying that you see, these can be turned into costumes, it can be turned into whatever props, weapons.
Yeah.
So sky's the limit.
Yeah, I'd like to see some tech support, some bitmaps, some GIFs, all that sort of stuff. So, yeah. Cool. All right, let's head on back over to the Learn Guide. All right, the circuit diagram is going to walk you through how all the wired connections are. You can get Adafruit fritzing parts from the link over here. We've got a little library if folks want to kind of put their own together. It's a great way to kind of visualize when you're putting it together and assembling. It's nice to have a visual representation of your circuit. So there you go. I got all the wiring connections broken out. Not too many, just 3 for the NeoMatrix. And the switch has 2 to the enable and ground. And again, the battery is optional, which I'll cover that here. For 3D printing, we offer all the parts. Even the acrylic was an STL in case folks want to print that out with maybe something else. I also offer an SVG file, which I will cover in the next page. But this one just covers the 3D stuff. So if you want the CAD assembly, it has an animation of the assembly you can check out. The original Fusion 360 share link is there. It's this Fusion 3.0. That's funny. I forgot the 6. And you can download them from Prusa printers and Thingiverse. That includes the NeoMatrix PCB file as well, which has like the onboard caps and the onboard NeoPixels. And we also have a GitHub repo, which that was newly added to it, so you can get that there if you want to make some 3D models using those parts. Yeah. Cool. All right, the next couple pages just walks you through setting up CircuitPython with your Feather M4 Express. So if you're new to it, this was going to walk you through setting up your board. It's relatively easy. Double tap reset button to get into bootloader mode. Drag and drop a UF2 file that you download, and then it automatically flashes itself and shows up like a USB drive, which is magical. CircuitPython libraries. This one uses the LED library, animation library, which is new to CircuitPython, fairly new. This one just walks you through the library bundle. Just walks you through unzipping it and looking at all the different things, and the example files are there. And it's very, very thorough. And then the code page walks you through actually uploading the code. You can use a regular text editor, but we're using the Mu editor. It's a nice lightweight Python IDE if you don't necessarily need one. So once you get your library bundle, you're just going to want these 2 libraries out of it. Put that in your lib folder when your CircuitPython drive shows up. That's your M4 Express. And you just want the Adafruit _LED _animation. That's a folder that has several MPY files, and then your neopixel.mpy file. So just those 2. This screenshot gives you a nice visual as what your drive should look like. A little note about the Python Mu editor. We have a Learn Guide on setting that up if you want to read through that. And then just some double checking things to make sure that you are indeed on the latest version of CircuitPython. You can look at the little boot out.txt file that gets automatically generated when you update your firmware, and it'll let you know what your hardware is running and what version of CircuitPython. And that just kind of gives you a nice double check. And here's the code. It is straight from the examples folder, a part of the LED animation library. So it's pretty much the same code. And then the only things you need to change is the digital pin. So in this project, we have it wired up to D6, but if you wired it to something else, you can change that here. And then there's 64 total NeoPixels, which is right here in line number 4. It says pixel num. And then for the pixel wing vertical and pixel wing horizontal objects, you want to just make sure that it says 8x8, because that is the kind of grid that we have here is an 8x8. If you had something else, you can update that here. I think this was originally written for the NeoMatrix FeatherWing, which does have an 8x4 arrangement, which is really cute. But this version, 8x8, really simple to just change those digits and have it working on a custom kind of NeoMatrix grid. Cool, and then we have a Learn Guide link here to all the different features and parameters you can modify. This one links to the pixel mapping, which is what you want to do when you want to kind of create horizontal and vertical grids. So there you go. Shout out to Kattni Roy for putting that together and make it awesome. After the code, I got a little page here on cutting the acrylic itself. So I put together this really simple template that you could print out on a 2D printer if you want to kind of reference the size. I have an SVG file as well if you want to see that like with a mill, or if you want to laser cut that, you would use the CNC file. If you want to print it, just print out the PDF vector file. So you can, that's what it looks like. Just a sheet of paper with the little square in the center. All right, and then I walk you kind of through how I set it up. This is just really for me, so that if I ever come back, because normally when I CNC something, I'll come back and I have to relearn everything because there's some gaps in between those projects. But hey, it's nice to kind of give you a rundown of the setup here. So I'm using the Bantam Tools Desktop CNC, formerly known as Othermill. They have a tool library for Fusion 360. Fusion 360, of course, has really nice CAM tools inside their manufacturing workspace. So you download this tool library, and this has all the common tools that work with the Bantam tools that are kind of set up for you, ready to go. So I got that in there in my tool library, and I'll walk you through how to install that with some text here. And I have a link to it as well. All right, and then to setup, you create a new setup. This is where you're creating your stock. You need to tell it, well, how big of a thing am I cutting? You add some offsets to the sides. We're gonna use a 2D contour operation, and this just walks you through like the essential stuff that you need to do or at least I need to do when I'm setting this up for milling. Selecting an 1/8 inch flattened mill is what we're using. We select the contour under the geometry tab. We enable multiple depths, and then we just add a 0.1 millimeter maximum roughing. Got some recommended settings, of course, from Bantam Tools themselves. Shout out to Bantam Tools for having nice learn guides as well. So I walk through their learn guide here, and it just gives me a good rundown of the exact feeds and speeds that are recommended for cutting acrylic. And various different tools has their own speeds and feeds. I'm using the 1/8 inch, which is kind of the biggest you can go. But yeah, those are the feed rates here for the acrylic, and they have some nice photos here and some more detail on cutting the acrylic. So that's why I referenced that, but these are kind of the settings that I pulled out of that. I have a G-code file here that is generated out of Fusion. That's only going to work with my stock size and my material thickness, so I really encourage you to make your own, because there are tolerances here, and the thickness varies from like 2.45 to 2.65, so you're going to want to accommodate that and modify it. And then for the other plan, that's the software that the Bantam Tools has. It's a really good piece of software, super easy to work with. Although I did try like importing the SVG into other plan because it has SVG support, and I was like, huh, this is not safe, because it has an error that says, make sure your material is properly like. Make sure your material is doable. Something about the material could break your tool bit, and yeah, you don't want to do that. You want to enable maximum multiple depths and cut at least 0.1 millimeters at a time to save your tool from breaking. Because I have broken many tools, and yeah, so yeah, this is pretty nice. So next time I want to do some stuff and I forget, I can come in here and read this through, and it tells you just exactly what you need to enter, which is nice. So that's other plan, Fusion, the tool libraries, and acrylic. Or you can just cut it with, a T-square and, and a scoring tool. That's hilarious. I'm thinking about it now. I actually went ahead and bought my acrylic cutting tool because I was like, man, this is too much setup. But if you're doing a custom shape, like a hexagon or something smooth with curves, that's where you would want to do this, and you would basically do the same thing. I'm just doing it with a square. Any questions about milling?
No, just that it'd be cool if these were all, if there was 4 of them chained together, which they are chainable.
Be dope, yeah. Yeah, for sure. Then I'd have to really use the MiniBoost, because that one's definitely going to eat 5 volts and not. Okay. So yeah, so that's cutting acrylic. Nice walkthrough there. All right, the next page just walks you through wiring up all the stuff, setting up your feather headers with your feathers. So they just, we'll just kind of run through it, but JST connectors are being used in combination with the 10 wire silicone wires, silicone cover, stranded core ribbon cable. It's about 28 gauge wire, which is our favorite type of wire. Yeah, lots of heat shrink too. All right, so when it comes to like the assembly, like what do you call it, the order of operations, you want to start with the PCB FeatherWing, the Proto FeatherWing, mounting that to the PCB mount in the right orientation, so you can reference the photos. I'm using just hex nuts and screws, but if you do want to use a battery and have more elevation, you can use the standoffs to elevate the Proto FeatherWing. Install the switch. That gets installed by press fitting it at an angle. It just stays there. NeoMatrix, just gotta make sure the PCB is oriented correctly with the standoffs. And then it's installed. Putting the grid, just make sure that the cutouts are lined up with the caps. Make sure your acrylic is facing the right way. Shiny side up, matted side facing down. Press fit it all together. Connect the JST connectors. And then power it up and turn on the switch. And then you have it. There you go. I just kind of ran through but you can walk through it thoroughly when you're building it if you do plan to do so. And that's the Learn Guide. You just kind of walk through it, ran through it. Here we are at the other end, and our animations are still running.
Super
I
cool.
really like that orange.
And we got some comments. Yanni is posting a link to maker.io on their nice little tutorial on making 3D parts with the Bantam tools. Nice little workflow.
That's cool.
Tutorial there.
Nice.
And
Thanks for sharing.
then some questions would this work with the black translucent or transparent filaments? It would probably look like this here.
Yeah,
we do have like the purple.
Yeah, I had
It's like a dark color.
Yeah, nothing comes close to black LED acrylic that I have seen. It really is like on its own level. I have not seen anything that does this. Like people were like, oh, you could use paper, you could 3D print the thing. Like nothing looks as good. I'm gonna try the paper and see what happens. Hey, this is just a regular sheet of paper, by the way. Here's the acrylic template. Look at that. And this is pretty opaque paper. Mm-hmm. That looks lackluster, but it does work. Go ahead and put the black on there. Just see like the magic. Oh, not that one. The good one. This one or this one, doesn't matter. Yeah, definitely the Adafruit one because it's thinner and more bright. So, yeah. Do we have a printed? No, we don't have a printed.
Some translucent.
Yeah, I have this.
You don't have some around
I was
here.
pulling it out, but it's definitely different. You remember this, right? This is actually 3D printed when I was doing the Neo Ring diffuser, and this was 3D printed, but I can't quite snap it out because it's got a really good hold to it. But yeah, even that doesn't really offer that much nice diffusion. I sanded it down and everything, and it's still kind of grungy looking, has texture to it, which is nice if you're looking for that kind of effect. But it's hard to replicate this effect. It really is, this one. So if anybody finds some cool material that can do it, and that's like common everyday material, let's take a look at it. Yeah. So this would be our second or third project now that uses the black LED acrylic. Our first one was like this heart thing. And you can find that on the Learn Guide too. It's heart. This one over here, this uses the black LED acrylic as well. And this has a link to Charlene's project, which inspired us to get black LED in the first place. She put together a little ring that uses a GEMMA, and she has a nice write-up on it as well. And she laser cut several pieces to kind of stack them together to make this kind of three-dimensional case. Shout out to Charlene again for the black LED acrylic. I don't know where she found it, but great job finding it.
Super cool.
Yeah, cool.
And then Electron Ash is saying that they just got their first RGB matrix, the 64 by 32. Have it hooked up to Arduino, but it's really bright.
Yeah, right? Yeah. Yeah, it's pretty bright. Yeah, the black LED acrylic works great on that. John's latest project uses black LED acrylic too. It's the clock project. It's using the 64 by 32 matrix as well. I think he's using the stand, the black wire this thing, and it just kind of rests on the front, so it stays there without any fanciness, which is nice. Cool.
Super cool.
Yeah. All right. That's going to do it for the project, I think.
All right. Let's go ahead and jump into this week's Woody prototyping.
Excellent. All right. Woody prototyping.
Yeah, so we were inspired by a couple of posts. Nick Dimelow?
I think it was Nick Dimelow. Right?
Dimelow.
Bugman 140 on the socials.
Yeah,
shout out to Nick.
Really cool 3D printed torch.
Yeah. With a GEMMA M0 and a NeoPixel ring. He's got this pretty beefy desktop fan, and the idea is to have a flame, like a fabric flame, inside the torch. So it's all 3D printed, kind of screws together, and the GEMMA and the NeoPixel ring are mounted. They're hot glued to the grill and the back of the fan. So I really like it, and I wanted to remix it and kind of recreate it with a GEMMA, but with a NeoPixel jewel and a smaller fan. So our little 5-volt mini fans that we use for our fume extractor. So in the inside of the kind of cage is the 7 NeoPixel jewel on top of it, on top of the fan, and then below the fan is the GEMMA M0. GEMMA M0 has a built-in dot star LED, so we actually have it lit up, so it's kind of giving you some light down. And the fan is a little 5-volt fan that has some pretty decent airflow. It's kind of loud. And what we're trying to do is get a bigger, we actually have the updated version here. It's got a bigger cage that allows more airflow. So we're running into that whole issue of just like, how do we get the best motion out of our fabric? So our fabric is, it's like this nylon mesh that's sometimes silk, sometimes not. But it's like, I forget what it's called, like scarves, like dancing scarves. We got a pack of them on Amazon for like $2, different colors. Cutting that stuff with scissors though leaves behind lots of frayed edges. Yeah. So we ended up investing into like a $20 foam cutting thing to create these cuts. You ever played with a foam cutter before? They're kind of neat. So nice job on the shapes there. They look nice and flamey. But yeah, we're gonna put it all in here, and we have these little 3D printed mounts that that'll house the GEMMA in here and the dual NeoPixel in here, and the mounting holes actually get mounted to the fan. So the fan has mounting holes that are exactly placed right here. So you have like everything's kind of revolves around the fan, and then inside the cage are these tabs where the fan gets mounted to. So you end up basically with a 25mm screw that goes down, and it kind of secures all these pieces together. So it's kind of neat. So I can take this out and show you that. The next thing I want to talk about is a new product that was added recently. It's this little itty bitty board here. This is called the Adafruit MiniBoost 5-volt. And what this does is it takes our 3.7-volt battery and it pumps it up to give me 1 amp 5 volts. So that means I can power this fan without having to have issues while powering the NeoPixel, because the GEMMA is only going to give you about 3.3 volts out. So what's great is like if you have a little GEMMA and you're trying to power maybe 100 pixels, well, those 100 pixels want more than 3 volts. So the mini 5-volt pulse is going to give me 1 amp, 5 volts. That's awesome. So I have that little guy wired in there to the V out and the ground pin on my GEMMA, and then the battery doesn't have anything fancy. The battery just hooks up directly to the GEMMA. The GEMMA has a built-in on-off switch, so you just turn it on, and right away you get all your LEDs, your 5-volt fan that's getting 1 amp, clean voltage, and my GEMMA's having a great time. So huge shout out to Lamar for putting together the MiniBoost. I think it's going to be great for projects that need a lot of power and a small little board like our GEMMA here. If this board wasn't here, the fan probably wouldn't power, or it would just keep browning out because it's trying to get 5 volts out of the 3-volt regulator. So that's really cool. Let me show you the product page for the MiniBoost. They are in stock, and they're only $4. I picked up like 4 of them because I plan to use these in all my Trinket GEMMA projects now that need 5 volts. So I think that's going to be a common issue that folks run into is like, hey, I'm trying to power this NeoMatrix. It's got 64 pixels, and like, you know, one of them is glowing green or something weird. It's because you need 5 volts. So the MiniBoost is your answer. Have you guys...
We got some suggestions from Foamy Guy saying that it'd be cool to add a bit of randomization to the timing on the fan, so we can have some randomization to the flame, giving it a flutter effect.
That would be cool.
That's a good idea.
That is a great idea. Yeah, I'll ask and see if I can get some help from the team.
All right, so that's going to be, I believe, next week's project. Got some parts printing up right now, and we'll see if we can get the flames to behave in a more sort of flapping way.
Yeah, we just gotta disassemble it and put all the things together in here. This is all nice too, it all screws together. I have a layer by layer on putting these threads together, but yeah, I like these type of threads because they're interchangeable, and yeah, you can do all sorts of fun stuff with props. With threads.
Super cool.
Got your little kit.
All right, sweet. And
Parts.
that is what's being prototyped for next week.
Yeah. Yeah. You want to do a quick shop talk?
Yeah.
Yeah. Well, we talked about the mini volts. Did we talk about the screwdriver?
No, we didn't.
Okay. I got an electric screwdriver. I know, like, hey, just use a regular screwdriver, but, you know, 25mm long screws are kind of whatever. This was like $38 on Amazon, and it came with a ton of tips and stuff. It's electric. It has a built-in battery charger and little LEDs here to indicate what the power is like when you plug it in. That's all it does. It goes backwards, it goes forwards. It has tons of little things. I got it on Amazon. Pedro, if you want to paste that link, it's in the notes. I had it open. No, I don't.
No, I haven't.
I had it open. No, I don't. So let me pull it up. Yep, that's it. And it went up in price by $1. Got it for $38, now it's $39.99. But yeah, it comes with all the stuff here, all these bits, and I've been looking for a good screwdriver that isn't $100, so there you go. And I think for little electronics and stuff, this works out pretty nice. So here it is, sorry. I didn't switch to it. So I got it on Amazon. It's about $40, and it's on Prime, so you can do that. And it comes with all the things. There are other ones from other different sellers. It's kind of like a white label, and everybody's kind of selling it at their own price with their own logo on it. But there you go. I thought I'd share about it because I've been in the market for an electric screwdriver that isn't $100 and just small and, you know, gets the job done. There you go. That is my
That's a little quick shop talk.
a little quick shop talk here. I got a new screwdriver. I like it.
All right, let's go ahead and jump into this week's community makes.
Yay! All right, every week we 3D print something from the community. This week, it's a little fun one. Something for the kids.
Yeah, so this is a fully 3D printed Duplo tractor. So it's compatible with all the Duplo blocks. And this is an excellent model by Riggy Track. It was made a couple of different Duplo type compatible models. This one caught my eye just because of the sheer amount of detail and the different materials that are required to build this, like the little tractor wheels there. And just the overall shape of it is super cool. I like all the detail all around there, and you can even add a little trailer on the back there. So we're using the lime green from Filicube. And yeah, it took about 27 hours to print all of the tires and the tractor part, the little roof, the Duplo blocks not included, obviously. But here's what it looks like. What camera I am at. And yeah, I am totally digging this. Of course, kids are digging this as well. These are Ninjaflex tires. This is the semi-flex. So we can print these on a Bowden extruder.
Yeah.
And yeah, all of the detail on this came out super nice.
Is it a fun assembly? Do you require a lot of supports or anything?
There was a couple of supports just on the axles, but that's pretty much it. Other than that, no supports needed on that. All of the things like the loader, that all comes off.
They all press fit? There's no glue going on?
It all press fits into place. And like we were saying before, here's the little loader part of that too. And you have a nice little way to attach that onto the back there. Oh, can't even see it. Oh man, I'm too close.
Let me go to the other camera.
There we go.
Had some stuff here.
And like I was saying before, it is all fully compatible, has a nice press fit tolerance with the Duplo blocks. And then, like we were saying before, the tires are all printed in the Semi-Flex, Ninjaflex, but any other flexible filament would
Is
do
it from
too.
Ninjaflex or from like Saint Smart?
No, this one is Ninjaflex, but
Okay.
again, you can use any 98A flexible filament.
Word.
And all these just press fit into the
Little joints. Little snap fit
what's it called?
joints.
Yeah.
Nubs. I don't know. Forget what they're called.
Yeah, it has a really nice tolerance for all the Duplos.
They actually fit.
Yeah. So
That's
excellent
awesome.
little model here if you want to have a couple of new toys for the kids to play with during quarantine and all that.
Cool.
So super cool.
All right, it's on Tinkerbears. Again, designed by Tarak.
Yep.
And he's got all the files there for you.
So he has a single
Multicolor.
extrusion and the multicolor one as well. So you guys have those material printers. Definitely take advantage of that and have it all nicely colored for you.
Cool. I think he has a couple of designs as well that all kind of have the same theme.
Yeah.
Oh, Thingiverse. Anyway, I got one last one here. It says like, no, things are here. It's like, there's 6 designs. What do you mean nothing's here? There it is. Nothing here yet. That's so funny. All right, well, the next thing I want to show you is a make alert. This is the first make posted on the socials that I've seen. So this was posted up by Thingiverse user Bruno Santos posted this up, and he posted some lovely photos of his LED Matrix Hourglass build using some nice glitter-filled filaments here. This looks great. I think this is the bigger version. It's hard to tell. Scaling's hard to tell. But it looks great. It's using 2 different colored LED matrices, but this is one of my favorite projects. Love the assembly. Great code by Carter Nielsen, who's on the Adafruit team. And it's always fun to see what printers folks are printing at, and I've never heard of a Flying Bear Ghost 3D version 3 printer. Flying Bear Ghost 3D. Very, very cool. So if anyone asks me what's a good printer, I'm going to tell them Flying Bear Ghost 3D version 3. Super cool. I think it's Filamentum's Galaxy Vertigo colors. They just have that certain look to them. But anyway, shout out Bruno. Thank you for posting that. That was the first make I've seen of this project. It was lots of fun to do.
Yeah, I like the color scheme.
Yeah.
And then over on the Discord, Andy Calloway is reminding us that the Duplos are indeed compatible with the Lego.
Sure. Yeah. It's just doubled.
Yeah. Or quadrupled.
Duplo Lego.
Yeah, it's actually one of the techniques I've seen when they do those very large Lego builds. They actually use the Duplo.
That makes sense. For the structural bases.
Yeah, for the bases,
the
or if there's
foundation.
like a giant amount of, like, say, one color, or like a mountain or something, they'll use a bunch of the Duplo blocks.
Cool. We're doing great on timing. We got about 10 minutes, so we're going to wrap the show up. Yeah?
Let's see, going through the notes. We got the hourglass. Yep. All right. That's going to be it for this show. Stay tuned later today. There were some questions about that awesome flexible OLED display that Lamar and Phil posted.
Everyone wants to know about this thing.
Yeah,
Me too.
I'm sure there'll be more guest appearances from it later tonight on Ask an Engineer, so definitely make sure you subscribe, turn on that notification bell icon so you can see when that comes up. I'm sure that'll be during one of the top secret sections.
Sure. All right. Well, right before Ask Engineer is Show and Tell. Starts at 7 p.m. Eastern Time. Happens every Wednesday. You can hang out in the live broadcast chat room at 6:50-ish, and then PT, Mr. Lady Ada, will drop in the StreamYard link where you can open up. Just make sure your mic is muted and your camera is all ready to go. Everything is fair game. Arts and crafts, electronics, maker spaces, tools, retro tech, what you're working on, notes. We've seen notes. We've seen lots of progress from various people. So really fun time. Great way to get your projects out there and get your maker's gonna make. And then shortly after, well, it's an hour long, after 8 p.m. Eastern Time is Ask Engineer time slot every Wednesday. Eastern Time, 8 p.m. Those are the two shows that are back to back.
Mm-hmm.
All right. Over Sunday, Lamar had a really nice stream, The Great Search with DigiKey. So she's doing every Sunday around 8 to 9 p.m. That's when she goes live. So thanks, folks, for coming in and saying what's up at those hacker hours. Tomorrow, John Park's doing his live workshop. It's every Thursday at 4 p.m. Eastern Time. John just did a virtual event, Maker Fair over the weekend, so check that out. It's on the blog if you want to take a look at his talk where he chatted about live streaming.
Yeah.
Live streams with the live streams.
Yeah, definitely want to
meta.
use the Pi cameras that we have, the high quality camera modules, to have it act as a streaming camera. Super cool.
Excellent, excellent. All right, well, we hope to see you tonight on the show and tells. We'll be there. And just a reminder, the programming note, this is 3D Thursday. It happens every Wednesday at 11 a.m. You can hang out with us in the Discord chat room, which we're hanging out now. And we have some lovely comments from folks. Thank you, Andy. Thank you, Jim and Yanni for the comments, and everybody else too. We did it.
Yay.
Yay, we didn't have any issues so far. It's great. And I can say that now because it's near the end of the show.
All right, guys, that's going to be it for this week.
Thank you so much for coming in, but until next week, remember, it's up to you to make a great day.
See you later tonight.
Bye, everybody. Stay safe.